characteristics of vectors and force fields. Error in the principles of inertial mass and the invariance of the speed of light. First principle. Instantaneous forces do not exist. All forces possess a finite velocity of action and motion. Force is synonymous with a dragging or pulling action. Therefore, each type and class of force must have its own intensity, I, and its own velocity of action or execution, VE. If this principle is not properly understood, or is overlooked, one may fall into the error of formulating incorrect questions and, consequently, arriving at inadequate solutions regarding force-related phenomena, such as inertia resulting from applied forces. This may occur, for example, when attempting to accelerate a body to the speed of light under the mistaken belief that, since this speed cannot be surpassed, the applied force is being converted into inertial mass. This is not the case. What actually occurs is that the execution velocity of each force corresponds to the maximum speed at which it can drag or transport any object to which it is applied. Let us consider a practical example. A drag force field such as the wind can only carry a feather, a sheet of paper, or a balloon at the maximum speed of the air current itself. Similarly, in vector systems such as the traction force of a train, a wagon can only be pulled at the maximum speed that the locomotive can attain. Therefore, in force fields and vectors, we may identify two fundamental components, in addition to direction. The intensity, I, and the velocity of action or execution, VE. Accordingly, the applied force, FA, defined by these parameters, may be expressed as is in diagram, where m is the mass, I is the intensity of the field, v is the velocity of the object being dragged, VE represents the execution velocity, which corresponds to c, the speed of light, in magnetic and gravitational fields. From this expression, it follows that as an object being dragged approaches the execution velocity of the force, the effective intensity of the force progressively diminishes, until no force is perceived when the object reaches the maximum VE. Thus, the relativistic notion that energy applied to a body at velocities approaching the speed of light is transformed into inertial mass lacks foundation. Rather, at the speed of light, no energy or force is effectively applied to the object when magnetic or gravitational vectors and forces are involved. Further applications of the complementary parameters of intensity and velocity in force vectors. By applying these principles to machines, mechanical systems, and electronic devices, and considering this dual component property, current, I, and execution velocity, VE, it becomes possible to transmute or interchange the values of these parameters. In other words, one may convert current into velocity, power into velocity, voltage into current, and so forth. An example of this can be observed in systems such as an automobile gearbox, which exchanges speed and power, as well as in electrical coils or transformers, and in classical mechanical principles such as the law of the lever.